This is the design, development, and demonstration of a 5-element Yagi. A Yagi antenna is a type of directional antenna commonly used for a long-distance communication. It consists of several metal rods of varying lengths, arranged in a specific configuration to transmit and receive radio waves. The 5-element Yagi antenna is a variation of the standard Yagi antenna with 5 metal rods instead of the usual 3. The 5-element Yagi antenna is a popular choice both for commercial and amateur use due to its high performance and relatively simple design. The purpose is to understand the process to develop and measure the antenna for bandwidth and gain. The frequency goal for the antenna for this class was to achieve 2.3 gigahertz. The design limits for the projects were to have greater than 2 dBi and could not exceed 15.24 centimeters in length, width, or height. In the design methods, there are several methods for designing a 5-element antenna. One common approach is to use a computer program or an online calculator that can generate the dimensions for the antenna based on the desired operating frequency and desired gain. Another method is to use the rule of thumb approach, which involves calculating the dimensions of the antenna based on the length of the longest element known as the boom, which is this right here on this figure. And then that figure demonstrates how tuning was accomplished by trimming copper metal until the desired frequency was achieved. And then this is my antenna that I designed here. In the development method, microwave beam antenna was to be completed on a printed circuit board or a PCB material as part of the antenna structure to evaluate performance. The PCB antenna was transitioned with a female SMA connector, which is stationed right here. The PCB material was the FR4 with a 4.7. Equations used for the Yagi antenna are shown below. The wavelength is calculated by the speed of light divided by the frequency you were wanting. So in this case it was 2.3 gigahertz, and that equaled about 0.13 meters. So this is switched into inches, and then half of that for the half wavelength would be 2.56 inches. And then the length of the driven element, which is this one right here, would be calculated out to 2.51 inches. The length of the reflector, which is the long one down here, equaled out to be 2.61 inches. And then the length of director, which would be this one right here, would equal out to 2.21 inches. Demonstration method, the antenna return loss, RL, bandwidth, and gain were measured to evaluate performance on a Keysight Fieldfox microwave analyzer. It was used for RL testing and indoor antenna range using a ratio meter. It was used in the space of 30 feet, which is beyond the Rayleigh distance. The transmitting source was set for 2.3 gigahertz. As a result, the antenna was tested and tuned for the best RL on the VNA. The result is shown on the graph below, which is right here. The antennas were held at a height of 1.2 meters to measure the gain compared to a reference antenna. Calculated and measured gain are noted in the table below, which is right here. So my antenna RL and dB was negative 15.5. It was calculated gain for dBi was 8 to 10, and then the measured gain for dBi was 7.5 dBi for the one I designed. In conclusion, the design of a 5-element Yagi antenna involves careful consideration of the dimensions and spacing of the elements to achieve the desired performance. By using a combination of a driven element, reflector, and director elements, it is possible to achieve a directional antenna. The 5-element Yagi design was successful in demonstrating how antennas are tuned for the best return loss versus frequency. Thank you.